Underscore batch. Let me just open the document. Okay. Otherwise, let me open like from here. Okay. You see my screen, right? You are able to see my screen now. So just please confirm if you can see my screen and if I am audible. Yeah, thank you. Thanks for that. Okay, let's jump to the discussion. We'll complete this OOP features today. I believe we had discussed almost all OOP features like object class encapsulation and then polymorphism inheritance. And today we'll complete polymorphism and also abstract classes that will that will give a complete idea about all OOP concepts. Maybe here and there we need to understand a little bit about collection concepts. That again, I told you, right? Tomorrow, from tomorrow, we'll switch to our Selenium and maybe collections in between, if any, and when that need comes, we'll talk in the middle. Okay, whenever that is needed, we will switch back to that. Okay, but for from tomorrow, uh, what shall we say? We'll go back to this now. Coming to the what shall I say? So this one, polymorphism, right? We know what is polymorphism, and we were talking about this polymorphism topic, and we did about discussed about this one. What is that? This compile time polymorphism, and we were talking about this method overloading in the last session, friends. Right? I hope this is clear. Right? So now let's sorry. Uh, in the last session, you remember, right? I was talking about what is method overloading. Same method with different method forms is known as a method overloading, right? And we can see here we have overloaded some method here, right, friends? So some method, but while overloading, we had discussed about two things. A couple of we need to follow a couple of rules. What are those rules? Rule one: either the name of method must be same for all the overloaded methods, but either the data type of each method should be different, or number of parameters should be different. So this is what we have discussed in the last session, that is maybe on Friday. So these are the rules we must follow when you are overloading a method. And second rule, and another important point, what is that? Sometimes people ask questions. Suppose if we change this return type, does that have any impact? So changing return type doesn't have any impact with overloading. Suppose if we just change only return type, now we have int here. This method is returning int, and this method is returning double. This might return some float, and another method might return some char. But just changing return type alone doesn't have any difference with overloading methods. So return type is not considered in overloading here. That doesn't have any impact on overloading. Only you see method is overloaded when the data types are different or number of parameters are different. And change in return type of a method, understand this point carefully. Change in return type of a method doesn't have any impact on overloaded methods. Okay. So simply speaking, this return type doesn't participate in overloading. That is the simple point, friends. Okay. In the last session, we were talking about this how to test it, right? So we called sum method, and here we have three different types of sum methods. So one is with int parameters, another one with double parameters, another one with int with three parameters, not with two. And if you don't try to keep these differences, if you don't try to add these differences, then it might be a method redeclaration, and that is not allowed in Java. You might run into errors. We cannot declare same method again unless if you change the data type of methods or number of parameters of method. That is what we call signature. As a whole, we call this whole thing, this heading, we call it as signature. The signature of overloading method should be different. How name can be same, but parameters should be different. In just simple one simple sentence, we can say name of overloaded method should be same, but parameters should be different. How parameters should be different, you must be clear by now. Either data type should be different, or either the other one is number of parameters should be different. That is what a simple idea about what is this method, what is this sprints overloading. And here, while calling, how this method binding happens, how your compiler is going to map a method call to a method. It depends either when you are making a method call, uh, you know, either the map binding happens based on the values you are passing here, either the values or number of parameters. In the first case, you have some method with integer parameters and some method with double parameters. But the question is, which sum is called here? Is that sum with the int parameters or sum with float parameters? Means in the first case, the first method itself is called for sure. How can you say? Because we are passing integer parameters, your compiler is going to bind this method call to this method only. Why? You are passing two integer parameters, and among these methods, which method is having integer parameters here? The first method. So compiler is going to bind this method call to this method, friends. That's all. In the second case, we have a method call with decimal parameters. Then in that case, your compiler is going to bind this method call with this method. So even though in the first two cases, the method call, the name of method is same, how this method binding happens, how compiler is going to bind this methods means simple, it's simple, friends. Here, compiler is going to bind methods based on either data type of parameters or type of values you are passing or number of parameters you are passing. And the third method is by default is mapped with this, the third one here in the program, math class. Okay, so this is how binding of methods happen. How binding of methods happen? So between a method call and the called method must means this one, friends. So what compiler is going to check here is how compiler checks. It sees what is the type of parameters and number of parameters here, and with method call what values you are passing and number of values you are passing. It checks both of this, and whichever is matching, that method call and that method will be binded. So this is how a method binding happens when we call a method call. Is this clear for all of you, friends? Is this clear? Do you understand this point, or shall I repeat this again? Can you confirm on this? Can you please confirm on this, friends? Is this point clear? Okay, so let me just again quickly summarize this. What is that? Here, when it comes to the method binding, so how this binding happens? While calling a method, how what compiler does is this binding happens by the compiler itself. This is static polymorphism. Here, everything is clearly declared. So compiler takes care of this kind of polymorphism. Okay. So in this case, what happens? So you have declared methods, overloaded methods, and you are calling them. In this case, how this method binding happens? So here we have a method call and we have methods here. While calling a method, compiler checks for couple of things here. Is method name same here and here? So what parameters you are passing, what values you are passing here. So, and these values are matching with which method? Is it with the first one, second one, third one? Which with which method it is matching? Definitely. So this will be matching with the first method. Why only first method? Because these parameters are integer, and here we can find the only matching method with the integer parameters is the first method. So binding of this method call will be done to this method. So this is how. So compiler checks and does binding between a method call and a method. Is that clear? Suppose sometimes it also checks for number of parameters. What is the method call here? Some. Okay, it sees it has to map with any of these methods. And what are the type now? Now it see how many number of parameters are there first. There are three parameters. First, it won't check for type. First, it sees for which method has three parameters here. So the third one has three parameters. And again, it checks for data types. So data types, we have three. So integers. The values are int type. So it sees a overloaded sum method with three integer parameters. Then that is this method only. So what now? The compiler will map this method call to this method. And this is the simple idea how a method a call is binded to a method. So this is very important uh, thing to understand, friends. Right. So this is an idea over. Now, once you call these methods, so what these do, the respective methods will perform that business logic and return that result back. Now we assign that to some local variables and print them. When we run this, this is the output we are seeing for this program. Now you can see here. And this is all about overloading. What is overloading means same method with declaring more than one method with the same name but different parameters. And this is called overloading. Usually this is applied for methods and the concept which we are doing here is overloading. And these kind of utility logics, we generally declare these methods as static methods so that while calling them, you don't need to create objects. So this is the advantage if the advantage with static methods. What is the advantage? We don't need to create objects if you are calling these kind of methods so that it avoids unnecessary overhead on the developer. So on the memory, at least not developer, on the memory. Okay. So this is the advantage declaring methods as static. So usually when we can declare methods as static, when we are implementing any utility logic, in such cases, we prefer to declare such methods as static. For example, if you see, if you observe this math class, let me just show you quickly so that you get an idea. Because you need to understand these things. Of course, I'm just not taking much time, just a few. I'm just opening command prompt to show you. And prompt. It's taking time. Sometimes it happens. It's okay. Let's not waste much time. CMD. Okay. It's okay. Let's check it again. Program files, right? Maybe we can check in that as well. I usually it will immediately show us. Okay, it's okay. I don't want to waste much time here. So I'll check and show you again. Command. Otherwise, let it be like that. Seems like it's not. I'll show you. See, generally, I'll show here just to show you quickly. There is this math class, you know, right? In java.lang package, we have this math class. Let me just show you math dot. Maybe here, let's try in this one. We cannot directly call in class area any statements. We have to call them in the this one in the methods math dot. Now all these are static methods actually. I just want to show you the signatures. That's why maybe I will do one thing. Open declaration. Yeah, declaration. I hope we should see. Yeah, this is the one. See here, friends. We don't need to go to command prompt. Sorry for taking some time. So this is math class, and you can see they declared this as a final class. Just to give you a quick idea, final means we cannot inherit this. That is what a final class is all about. And you can see almost everything in this math class. If you see here, everything in this math class is declared as static. You can see here, everything, every method, every variable, all these are static. You can see all these methods in the math class are declared as static. See here, friends. Okay. So why these are declared? Because these are all utility methods. Utility means some kind of mathematical logic. So these are independent from objects. So that's why such methods are declared as static method. You got it right? I just want to give you a quick idea. So when we should declare a methods as static means usually when you are creating mathematical logics or any utility methods, then they should be declared as static. And in overloading here, you can see I just made this as static so that what happens, we don't need to create objects here while calling these methods. And if we don't create objects, this avoids unnecessary overhead on memory, right? This is a quick idea, friends. This is all about overloading. I hope this is clear for all of you, right? So let us jump to the overriding. So the another concept of polymorphism, overriding. But before I jump to that, I believe you are clear with the what is that, friends? Overloading. Let me just yeah, this is the one. So I hope now you are clear with this overloading. So what is overloading? The process of defining, sorry, defining same method in multiple forms is known as overloading. By now you should be very clear with overloading. Then rules for overloading. The name of method must be same, but the parameters should be different. So what is that? Name of method must be same. Parameters should be different. Or that is what is that parameter should be different. Data types of parameters must change or number of parameters should change. That is the rule. And we have seen examples. So, and here, what is the purpose of overloading if someone asks you? So it's simple, right? To the same method, we can pass different parameters. Suppose while calling sum, you can pass in parameters to that. You can pass double parameters to that. You can pass float parameters to that. You can pass short parameters or string parameters. You can pass anything of your choice. Depends on requirement. So to the same method, we can pass different parameters. So we can have this kind of opportunity if you overload methods. I hope this is clear for you. Understood now? So that's all about overloading, friends. And we had discussed about binding, method binding as well. So I hope you should know what are the parameters we should follow while binding method. You can see here. While calling a method, a compiler considers the following characteristics. What is that? Name of method, number of parameters, type of parameters. We have already discussed these things, okay, in today's session. Now, I hope I'm stopping. I'm winding up this overloading topic here, or concluding overloading topic here. Let us jump to the overriding concept or runtime polymorphism. Before I switch that, I hope you are clear with this. Which one, friends? Overloading scenario, right? You should be clear with the overloading, right? Yes or no? Please answer in the chat box if you are clear on that. Still, any problem? Maybe you can go through the recording. That might help you. That's all, friends. Next one. What is runtime polymorphism? So just now we had discussed what is that? If method binding happens at the time of compiling program, it is a compile time polymorphism. What is runtime polymorphism? If the same method binding happens at the time of executing a program, and that is called runtime polymorphism. And we implement runtime polymorphism using method overriding. So how do we implement runtime polymorphism? We do that using method overriding. Now the question is, usually runtime polymorphism occurs based on object. But that here, this occurs based on object. I will explain this quickly. What is this based on object? But these are important points to remember, right? So next one, method overriding. What is method overriding? Now that is the question. So now we are going to talk about runtime polymorphism. But if we should discuss that, so here we have to introduce to the concept of method overriding because we implement a runtime polymorphism using method overriding. So what is method overriding? The process of declaring method of a superclass in a subclass. So you have a method in a superclass, you know inheritance, right? By now we had discussed inheritance. So you have a method in a superclass. Now you declare same method of superclass in subclass with same signature. Again, here signature is same. But what is different here? But with a different implementation, signature is same. If it is overloading, signature changes from one method to another method. And usually we overload methods in the same. If you see in the program, overloading happens within the same class. Overloading happens within the same class. Overriding happens between a superclass and a subclass. And here, the method of superclass, whatever that is there, that we implement in the subclass with the same signature, but with a different implementation. And that is what we call method overriding. I understand, right? So I hope this is clear. If the definition is not clear, let us see a small example quickly to understand the concept of overriding. Okay. So here, let us take a simple example. I don't want to confuse you by taking any complex examples. So what do you do right now? First, understand definition. What is overriding? Declaring method of superclass in subclass with same signature. Same signature. Don't get confused. Here signature is same, but different implementation. For example, let us take a simple example. So here I'm taking a new file, new, let me just take it as a right click, new class. What shall I say? This one is override demo. Okay, Leo, there is a small typo. Ignore that. That doesn't have any big issue for us. Put main inside this. Now take one class. And we shall we take it as a class test or something? Class parent otherwise. Let's take like this. Okay, just take a simple method here. Let's not complicate. Take a method of superclass. Public void m1. Okay, this is simple method of superclass. So here, what do you do? Just declare hi. This is from parent. So this is what a method in a superclass. Now you declare a subclass, right? First way, do what? Declare a subclass, class child, and then extends parent. So now we have a superclass and a subclass, right, friends? So now what is happening here? Superclass is a parent and subclass is a child. So what we are doing here? This method of parent, this method of parent, we are overriding it in subclass. Now, what do you do here when while overriding? Same, just copy the same method, paste here. Your signature should be same. Means the method definition should be same, right? But you see here, implementation should be different. Implementation means body should be different. Internal statements of this method should be different in a subclass. So here, copy this and just make a small change. Of course, here we are just adding some print statements, but in a real code, the business logic changes from parent method to child method. Okay, here you can say, hi, this is from child, something like it. You can write whatever you want, friends. This is from child. Now, this is a quick idea about overriding. So what did we do now with a small example? We just have a quick idea between a parent, between this superclass and subclass. So we understood what is overriding here. Overriding is nothing but defining a method of superclass in subclass with same signature but with the different implementation. Here, if you see, the signature of methods are different. Signatures are different. You can see here. Now, this is the method of parent. We define same method in subclass. Observe this carefully. But what is different here? Definition is different. What is different? What is different? Definition. Sorry, I'm sorry. Implementation is different. You can see here in the body of parent we have some implementation. In the body of child we have some other implementation. So means what? This is what you should do when you override a method. When you override a method between a parent and subclass, so the signature of method must be same, but the implementation should change. So this is a quick idea about overriding, simply speaking. Is this clear to everyone, friends? So what is overriding? Overriding means declaring method of superclass in subclass with same signature, but with different implementation, different body, different logic. So you can see, I just took a funny example here just to have a quick idea. There is a class method marriage in the parent class. Usually parents ask kids to ask to marriage, right? Marry. So we just added a marriage method. Parents proposal is to Subbalakshmi. Okay. So class B extended A, which is child. But this child doesn't want to marry Subbalakshmi, which is chosen, who is chosen by parents. So what the child wants to marry some other girl, okay, or a boy, anything of girl or boy choice. You can take as you like, okay. So he changed his decision by marrying another girl called Lekya. Got it right? So what is here? The method of marriage is same in parent and child, but difference is what parents wants kid to marry Subbalakshmi, but child want to do the same marriage thing, but he want to marry Lekya. So what is the difference here? There is a change in business logic here, come from parent to child. Even though the name of method is same in both classes, the business logic or the logic in the method changes. This is simply speaking overriding. Overriding means what? Already something is there, and in place of that, you keep something else, right? That is what we call overriding. Simply speaking, there is a method in a superclass. Simply you override that. Override means definition will be same, but implementation is different. So that scenario is overriding. Just remember, and this is very much followed in a real time cases. Also, you might see this overriding in many examples of this APIs. APIs means built-in libraries. Many where we can see these methods are overridden. Okay, or we can call it as overridden. The exact technical word is overridden. Is this clear for all of you friends? Now, these are the rules to override. What is that? By now, you know the rules anyhow. What is that? While overriding, what is the rule we should follow here, friends? Signature of method must be same in both superclass and subclass. That is first rule. Signature means what? The definition of method, return type plus method name plus parameters. We call it as return type. Sorry, signature or definition. So, and again, another important point. We may have change in return type while overriding method. And such change in return type is called as covariant return type. This is another quick scenario. So I'll talk about it. So when you override method, so if you see this example, sometimes we can have a change in return type of parent to child. So here, what is this friends? Here the return type can be some X and this is the return type can be Y. And this change here we call it as covariant return types that I'll talk about it. But this is the concept of overriding. I hope this is clear. Now, what do you do? Now go to this test class. Now create object for child or parent friends. So quick question. Already we know inheritance. Should we create object for parent class or child class? If it is inheritance, we know. Always recommended to create object for parent or child friends. Which one? Please answer in the chat box. Where should we create? In a child class, yes. So now create an object here. See, you can see here. Child space C equal to new child. This is scenario one. Okay, next one. There is one more scenario here. Parent space P equal to new child. This is scenario two. Okay. And then you are calling C dot M1. And here P dot M1. There are if you observe in this program, we are declaring objects in two ways. In the first case, we are creating object of child class. You can see here. And here how we are straight away creating object of child here. So this is one way of creating object. This is straightforward. The object of child here, and we are calling a method of method on child reference. Second scenario. What is second scenario here? A parent reference is referring to a child object. This is something new for us. Actually, this is how we should create objects when you are working with a real-time code. So what is happening here? So here, when you come to the inheritance, especially this kind of declaration, this kind of object declaration happens when you do method overriding. Now in the second example, in the at line 18, you can see we are declaring an object where the reference is parent and object is child class. Got it, friends? Now the question is, when I say p dot m1, which method is called? Which method is called? Is it m1 method of parent or m1 method of child is the question. So what's your answer, friends? Leave about the first one because first one is straightforward. The object belongs to child. Reference is child class reference. Object is child class object. So definitely this method m1 from the child is called. This is called. But in the second case, we are referring to parent, but object is child. Okay. So this is how we create objects in for usually when we have this polymorphism implemented, runtime polymorphism implemented. Now the question is which method is called here? When I say p dot m1, is it the subclass method or is it the superclass method? Which one is called when we initialize like this, an object like this at line 18? Please answer in the chat box. Which method is called, friends? Is it the subclass method is called or superclass method is called? So some of you are answering child, right? Shankar. Shankar is answering child. If a child class method is called, why child class method is called? Why not parent class method is called? Because here simple, friends. In overriding, we we initialize a child class object to a parent reference, and reverse is not applicable, is not possible. We cannot assign a parent object to a child reference. Don't do that. But a child class reference can refer to a parent class reference can refer to a child class object. Repeating, in Java, when we are implementing this polymorphism or overriding, so what we can do, a child class, a pair, sorry, I'm reframing, a parent reference can refer to a child object. So, so here, if this is parent reference and this is child object. Okay, friends. So now, in this case, if you are checking here, now here your compiler cannot decide which method to call. So when I say p dot m1, we have m1 in the parent, we have m1 in the child. Now this is an ambiguous situation for compiler. So compiler cannot do this method binding in this case, where in this for this method call. So who will do this method binding? JVM will do this. So what happens here? JVM will check here there is a reference, there is an object. Now the question is JVM checks whose object is this? It checks for object. Whose object is this, friends? This object is a child object. So now what happens, friends? JVM is going to call a method from child class. That's all. Simply speaking, it sees whose object is created here. It says if it is child object, blindly it will call this method, this p dot m1, this method from the child class itself, not from parent. And here, method binding happens based on object. It sees the object. It doesn't check for reference here. It don't care about whose reference is it, but it checks whose object is that. The object belongs to subclass, so the method from subclass is called here, friends. And this approach is called as a dynamic method dispatch. What is it? Dynamic method dispatch. And usually, this in this scenario, the method binding happens at runtime based on object. That too, JVM do this method binding. In previous case, if it is overloading, compiler takes care of method binding. But in this case, as this is what is this runtime polymorphism, and you are applying this concept of dynamic method dispatch, where a superclass reference refer to a subclass, and in this case you are calling a method on parent reference. Now this kind of binding, this is done by the JVM. Compiler cannot do this binding because it is not sure. There is an ambiguity compiler. So here for compiler, when it checks for this method call, which method should be called? The method from the parent or the method from the child? This is not decided by the compiler. So at the time of executing program, JVM decides which method to call based on this object. And this scenario, this approach, we call this as dynamic method dispatch. I hope this is clear. This is one of the very important use cases in your real-time programming. And this is a quick idea about what is it, friends, about overriding and rules to follow overriding. So, and third one is what is dynamic method dispatch. So, fourth point. So, does a parent reference can refer to a child object in Java? Is it possible or not? So, if it possible, what happens in this scenario? And fifth point, in polymorphism, runtime polymorphism, is method binding happens based on object or based on reference. So after attending this few this thing discussions, you should be able to answer all these questions. Let's run this program now. In the first case, you might expect the output from the child class directly, no doubt. In the second case also, you expect the output from the child class, because in both cases objects are from child class. So the method from child class is called here. So what do you do right now? Right click and then say run as and then Java application and then proceed. And you can see in both cases the output is from child. Out of curiosity, you might ask a question, where Manoram, why don't we flip this and check this? Can a child class reference can refer to a subclass object? Is it possible? As far as I know, this is not applicable. Why? If you see here in a real world, always parents are inherited from superclass from father to kids, not from kids to father. This maybe kids might take care of parents, that is a different case, but inheritance happens from elders to youngers, not the opposite. Similarly, in a real programming, here a superclass reference can refer to a subclass object, vice versa is not applicable. But out of enthusiasm, you try to do that. Suppose you see here, this is a very important concept. Child CH equal to new parent. If you try this, maybe out of curiosity, if you go and try this, what happens? Let's see this now. First thing, when you do this in the beginning itself, you can see there is a compilation error here. Of course, put semicolon, no problem. So here we created object, but compiler is not allowing to do this. What is it saying? Cannot convert from parent to child. Okay. Forcefully, I do explicit casting. Now you can see I have done explicit casting and converted parent to child. So this is fine. Now the error is removed. But still, but still, this is not going to help you, because when you run this, you can see here, friends, run as a Java application. Okay, run this now. Proceed. You can see here we have class cast exception here, friends. What do we have here? Class cast exception. Right. Understood now? Excuse me. Okay, friends. What do we have here? When you try to do this, what we are doing here? A subclass reference is referring to a parent class object. And in this case, what's happening here? So one thing is we face two problems here. At stage one, if you directly do this, observe this carefully, friends. If you directly do this, you get a compilation error, because this is not allowed directly. Point one. Right. Point two. What is point two? You can do a casting. You don't need to remember, understand all this, friends. I'm just showing you. If you think it is useful, try to understand and apply it. Else you can ignore it. So there is no force on us. Apply cast here. When you do this cast here, what happens? Error is removed. But still, somehow we did explicit casting and we removed the compilation error. And now we are trying to run this code. When I run this code, still there is a problem here. Why? You can see we are seeing a class cast exception. Why class cast exception? Now you can easily understand. Read the error here. Parent cannot cast to class child. You can see here. It is clearly saying parent cannot be cast to child. This is a quick idea, friends. Understood, friends? This is a quick understanding and pros and cons about overriding or runtime polymorphism. I hope this is clear for all of you friends. All of you are good with this. So I have covered many things. Let me summarize so that if any confusion is there, that can be eliminated. One, what is overriding? Declaring method of parent in a child with same signature, but with a different implementation. With a different implementation. So that is overriding. So next one, what happens in overriding? Here there is a simple concept of dynamic method dispatch. What happens in dynamic method dispatch? A superclass reference can refer to a subclass object. And here, while calling a method, which method is called? A child class method is called. This is nothing but here what's happening? This method binding happens based on object. And this is one more important point you should notice in overriding. Right, friends? So then if you try to do the opposite, so can a child reference can refer to a parent object, friends? Is it possible? Can a child reference can refer to a parent object? Is it possible? Here we have two issues. One, if you do it directly, it leads to compilation error because this is not allowed. And still you have done explicit casting. Forcibly you have converted to parent object to child and you try to run it. Still it leads to a class cast exception. And class cast means you are doing a casting that is not legal. So at compilation level, still you can bypass this, but while executing your JVM doesn't allow and try to throw a class cast exception. Just remember this carefully. In future, in Java, you might come across these kind of issues number of times, friends. So just remember this. This is a simple, very important use case. Okay, that's all. I'm removing this now, and this is all about overriding. Understood now? Understood, friends? So that's all, friends. This is all about overcome polymorphism. Polymorphism means what? So same name with different, with different forms. Generally, that is applied to methods. And we have compile time, runtime. Compile time is implemented with overloading and runtime with the overriding. You can see here, right? So overloading means same method with the different signatures. Overriding means same method with the different implementation. So overloading happens within same method. Overriding happens between different methods. Okay, sorry, overriding happens between parent and child classes or super and subclasses. Right, this is all about all OOP scenarios. And before we close today, I would like to discuss the concept of abstract classes. I'll just take few minutes and close this abstract concept. Maybe we'll talk about what is it? We'll switch back to Selenium concepts from tomorrow onwards. Okay. So dynamic method dispatch, all this we had discussed. Abstract keyword. What is an abstract, friends? Abstract means simple, friends. Let me just get back to that abstract concept. Abstract. So this concept will be there at the beginning of polymorphism. Let me go back. This is actually a detailed Java session. So this anyhow, if you try to discuss all this, it takes at least 2 or 3 months to cover all this. I'm just discussing whatever that is needed for us. Anyhow, this is last session we discuss here. Maybe I'll cover collections once we do few this what shall we say our Selenium sessions. Later on, when we come to that topic, if it is needed somewhere, these collections, then I'll talk about it. Okay. So what is an abstract keyword? It's simple, friends. Generally, this is declared with methods and classes. Okay. And now what is an abstract? First, if you want to understand the abstract class, you should understand abstract method. So let's see what is an abstract method. See here, friends, simple speaking. So first thing, abstract is something a keyword which is a modifier declared with a method or a class. But the point is, if you should understand abstract classes, before that you should understand abstract method. Now the question is, what is an abstract method? Simple. Here if you see, I'm just giving you a simple idea to understand. A method without body, no body. A method without body is abstract method. Even if you don't put this keyword abstract, and still it is an abstract method. Technically, to make sure that this is abstract, excuse me, friends. So here we should add this abstract keyword before that method signature. And this is an abstract method. Abstract means simple, friends. Method don't have a body. An abstract method doesn't have any body. No opening braces and closing braces. And we should terminate an abstract method using a semicolon. At the end, we make sure you declare abstract method with the semicolon like this. Right? This is a quick idea. Understood now? That's all, friends. I'll just take an example and explain quickly so that we can close this topic. And from tomorrow, we jump to our Selenium topics class ABST abstract demo. I just take just only few minutes. I don't take much time, friends. Okay, again, I took a typo, leave it. So you take a class here, some first thing, some A. If A is there, I will add some A11, no problem. A1 is there, A11. Let's take this. So this is a class. Now I'm declaring an abstract method. So void M1 semicolon. Don't put body. But still we see an error here. Why? This method don't have a body. Unofficially, this is an abstract. If it is doesn't having body, that means it's an abstract. But technically, you should declare in a program to make this valid abstract method declaration. So if you want to make it a valid abstract method declaration, what is that you should do? You should declare this method explicitly with abstract keyword. Abstract, maybe if you can add some access modifier. Now it is default. Maybe you can put public if you want. Even if you can leave it, you can leave it default. Default access modifier. You can leave it with the default access modifier. But now the method you declare in this class is abstract without means it is without body, and such method is an abstract method. And you have declared an abstract method in a class, right? So then the class also must be declared abstract. That's why you can see an error with class here. Now you can see what is it? What is it saying? A11 must be an abstract class to define abstract methods. See here, friends. It's saying the type A11 must be abstract class. Why? Because if you declare an abstract method in a class, then the class also must be declared as abstract. Okay, so these are quick important points. Let me summarize. What is an abstract method? A method without body and generally declared with keyword abstract. That is point one. Point two, if you declare a method in a class, then that class also must be declared as an abstract class. So here, just simply say abstract class A11. Now this is a quick idea. Now what's happening here? So we have declared abstract class and abstract method. So that's the quick idea. Got it, friends? So now finally you understood, right? What is an abstract keyword and how to declare abstract method. What is an abstract method? A method without any body. And how do you declare this abstract method? By using keyword abstract. Just put this abstract keyword before this method, it becomes abstract method. Now again, what happens if you declare abstract method in a class? If it is a regular class, regular classes don't allow abstract methods. If you want to make, if you declare abstract method in a class, then that class also must be abstract. So declare the class also as abstract. So now you should be very clear. What is abstract method? What is abstract class? A method without body is abstract method and it is declared using keyword abstract. Second point, if you declare a abstract method in a class, then the class also must be declared as abstract. And that is very important point. So that's why here, once after we declare abstract method, see immediately we see an error with class. So then what did we do? We have changed the class to abstract. Now the error is removed. And other important points is inside an abstract class, we can have both abstract methods and normal methods. So if you want, you can declare something like void empty. And this is a normal method. So you can see hi, say hi. Means what? An abstract class can have both abstract methods and non-abstract methods. Non-abstract means normal methods. Is that clear, friends? Another important point is, but here the point is, if at all, understand, observe this point carefully. If at all, if we should declare abstract method in a class, then definitely the class also must be declared abstract. It cannot be a normal class or a regular class. If we should declare abstract method in a class, it must be abstract. But inside abstract class, we can have non-abstract methods like this, concrete methods. These are concrete methods with body or concrete, without body or abstract methods. Right? It can have regular methods as well. Is that clear, friends? This is a quick idea about abstract method and abstract class. So what is that we should do? We must override abstract methods of abstract class in a subclass. Another important point. What is that we should do? Where should we override abstract methods? We implement abstract methods of a parent in a subclass. Now you take one class here, class B11 extends just few 2-3 more minutes, my friends. That's all. Extends A11. Open this. Now what do you do? Override M1. This is the abstract method, right? Override that here. Void M1 and then body and then put some print in that. Okay. So this is M1. Okay. You can just add. Okay. This is implemented method now. So what did you do? Simple, right? This is a simple. The abstract method of this parent class abstract is overridden in a subclass. Is overridden in a subclass. This is the rule. A subclass which extends abstract class must override all abstract methods of its parent. If you don't do that, then the subclass also must be declared as abstract. Another important point. I'm just giving you very slowly explaining this so that it's easy for you to understand. So rule is, if a subclass extends abstract class, all abstract methods present in that abstract class must be overridden in the subclass, immediate subclass, else the subclass also must be declared as abstract. That's all, friends. Now go to test class. Now what do you do? Create an object for subclass. You don't need to do anything. Simply create object for subclass. Okay, here just create B11 B equal to new B11. Okay, and B dot just call that which one? M1 method. That's enough for us. Now right click and then run as Java application. Proceed. Now you can see the output we got from is from abstract method. I hope this is clear for all of you, friends. So that's a quick idea about what is an abstract method, what is an abstract class, where should we override abstract methods, and what if you don't override all abstract methods of parent, and then just test your overridden method here in the this one. Maybe in this scenario, still you as this is overriding is involved here. still you can follow this dynamic method dispatch if you want. You can create a dynamic method dispatch parent class reference pointing to subclass object. Why? Because we have overriding. Wherever there is overriding in that case or in that scenario, so you can apply this dynamic method dispatch concept. I hope this is clear, friends. I know this is too long for you today. Just I want to finish this abstract concept so that we can switch to Selenium from tomorrow. This is all about all our OOP concepts, friends. Is this clear for all of you? I believe these concepts are clear and without any confusion to you. Are you good here, friends? So we completed all OOP concepts. Tomorrow, let's switch to the Selenium. Any questions? Any questions, friends? If not, we'll stop this session here and then let's start Selenium tomorrow. Right. Thank you.